Good afternoon, everybody. My name is Mariah. I will be your host today. We will be having Mark from the Kaibab National Forest moderating our chat and questions, as well as myself. So if you could put them in the chat or the Q&A options on the right-hand side of your screen, and we'll make sure to keep track of those and ask them as they come in if needed or at the end. Again, this is welcome to your session, and Mark will be introducing our speakers.
Good afternoon, everybody. Welcome to kind of what is our final LiDAR portion of the AGIC conference. I am very excited today to have Arthur Crawford here. For those of you who caught my presentation yesterday, I referenced Arthur a number of times in my work with trying to map trees. Arthur joined Esri's professional service division as a technical manager at the Esri St. Louis regional office in 2000. He has more than 25 years of experience in cartography, terrain analysis, remote sensing, LiDAR, photogrammetry, and GIS. He currently supports the content team in the Living Atlas with ArcGIS Online, where he's a subject matter expert for raster to vector conversion and extraction, contours, spot elevation, vegetation, terrain data, LiDAR, and imagery. He's been involved in quickly turning cities, counties, and even the country into 3D using LiDAR data for extracting buildings, trees, and developing several of the processes behind this for 3D Basemap Solutions. In 2013, he won the technical certification for the ArcGIS Desktop Professional Award. So we are thrilled to have Arthur with us here today. I always love working with Arthur. He's got always very cool stuff, and he's a big supporter of our LiDAR initiative here in Arizona. So Arthur, take it away.
Okay. Can you hear me?
Yes, we can.
Okay. I'm going to share my screen and stop sharing my video. Sometimes it gets bogged down here. Okay, today I'm going to be talking about using ArcGIS to create 3D cities using LiDAR. And the main solution to do this with is the 3D Basemap solution. And this has been around for many years now, and it just keeps on developing into more and more of a program where you're able to easily bring in your LiDAR and other 3D data and be able to visualize it and use it as a 3D base map. So what we're seeing here is actually a scene in Europe of where they're looking at some flood analysis, but they're using a mesh and colorizing some of the meshes based off of different attributes on them. So getting value out of your LiDAR and imagery with 3D Basemap solution. It's a way to leverage and maintain all your 3D layers in a layer, and also to create those layers as they go in. So one of the things about it is it's a ArcGIS Pro project with task-based workflows that allows you to create numerous different types of 3D objects that go into your base map. So you can build, one of the new ones just came out is bridges. Buildings have been there for quite a while. You can divide your buildings into different floors if you want to represent different floors. You can take your LiDAR and colorize it, which is where you take your imagery and your LiDAR and you combine them to where each point has values of red, blue, and green, and even infrared or other colors. You can also create your elevation layers through it easily. So you can bring in your elevation and then output your LiDAR, and then create from your LiDAR both the DTM, DSM, and the normalized different surface model all at the same time. One of the new things that we've added is you can actually use artificial intelligence to collect your power lines and your power poles, and then convert those over to symbology that's procedural to where it shows the lines and the poles like this in here. And trees, of course, which are a specialty of mine. That's something I've been working on for quite a while, and some of my tools were used as prototypes for the tools in here. We've recently also added underground pipes, which is where you're actually able to take your sewer pipes for your cities and counties, and be able, if you have the height information on how deep they are underground, and the sizes of the different features, like the sizes of the pipes, you can actually represent them in 3D underneath the buildings, underneath your normal 3D base map, so that you can see how they relate to features on the ground. One of the other things that we're bringing in is modified meshes, and modified meshes are just meshes where they take photogrammetric point clouds. So they take photos from multiple angles and they create a mesh out of it. And those meshes are available from several different vendors that I'll mention. And you can kind of see on this little movie clip here where it's taking the LiDAR as is and be able to extract out the buildings and the trees and the bridges. And this, of course, is a mesh at the bottom. So what is a 3D base map? A 3D base map can be anything that you throw into 3D that you want to represent as sort of your base map that you'd lay other operational layers or other analysis on. The easiest way to get to a 3D base map quickly is just download your LiDAR, or if you have it on a drive, and if you have imagery for your city, your county, or even a state. I've helped 2 states colorize their LiDAR for the entire states. And one of them is this in Connecticut, is where you just take the LiDAR and you can colorize it with your imagery. If you want the trees really to pop out, NAPE is great for colorizing the trees, as it is in this scene for Connecticut. And it really just brings out the 3D easily. And then I'll show you some tricks to where you can actually fill in the sides of the buildings as well. 3D features, you can generate your 3D features either from existing data that you have. A lot of times data from, if you use Eagle View collected data or other data sources, you may have a height in there. And you can take your 2D building footprints that you already have and run them through the 3D Basemap solution, and it will actually get the roof forms for them and the heights. You can extract the trees from it that way as well. And then this is kind of exciting, is that there's some of the European countries are really going all out on this and creating kind of sort of a hybrid of multiple different inputs of data. So the scene on the bottom right is where you actually have the trees are being displayed with a colorized point cloud, but they extracted the trees as features too, and they're showing the trees as also cylinders to show where the trunks are. And then on top of that, they have some of their buildings there, or most of their buildings, actually as a mesh. So they have individual meshes for the buildings. And the mesh trees don't always look great, so they've removed those and just used the mesh buildings to represent the really high detailed buildings there. And then you see some gray buildings there as well, which are the buildings that are from AutoCAD or some other CAD software where they've built them out, maybe even SketchUp, where they built them out, where they have the real high detail that they wanted for those buildings, a church, then also a castle in the background there. So what can you use the 3D base map for? You can use it for urban planning. That's probably the biggest use that's out there right now. We have an urban solution which allows you to integrate your parcel data, your 3D building footprints, your trees, and be able to help you plan out with your parcel data and your zoning conditions where you might be able to build, how large of a building you can build there, what are the restrictions on heights. All that can be factored in there so that you can quickly show somebody how big of a building they can build, what type of building they can build with the building restrictions, and display that. And also go in and look at maybe parking around the area, how much parking they're going to need in representation to how big the building is. All that can be factored in very quickly and automatically with the dashboards they have. Situational awareness is big. It's where you can bring in other data forms that you have. So you may have emergencies where power lines are down, or fires, or crowd control or anything that comes up, or even being able to know which buildings are vacant. The city of St. Louis did that, where they wanted to see in 3D where all the buildings were that were vacant and see them and see where they were located and what they were near to each other. Transportation can be brought in to where you can actually have the transportation, and I've seen it where they actually have cars that will drive through on the streets, or bus routes, that buses that will actually drive through the city and show you where the buses are going to be at different times. Asset management is another one. Being able to take your normal 2D features such as trees or power lines or traffic signs or anything really that you have, and be able to visualize it in 3D and see how it interacts with the features around it. It may be that your trees or your point clouds from your LiDAR might even show things that might be in the way of a signage or any other feature, and be able to do that analysis in a 3D environment. Flood planning is a huge one, not so much for Arizona, but for the rest of the country, flooding and knowing how high water is going to get. And we can actually visualize that water as just a polygon. We can elevate it to the height. We can also display it with our new symbology to where it shows off as shimmering water and reflections in the water. And you can bring in your point cloud to your mesh or your point cloud and have that as part of it as well. One of the big ones was forestry management. Yesterday, I was actually talking to the Iowa Geographic Information Council. And about a year ago, they had a derecho go through, which is a huge windstorm that knocked down about 80% of the trees in their county. And I got asked by our disaster response and the county and the city of Marion to find out where all their trees were in their county. So they had LiDAR before, and they're getting new LiDAR flown this year. So they'll be able to take the trees that I extracted from before the derecho and be able to compare it to the trees after, and be able to understand exactly how many trees they lost and in what areas and how big of that was an issue. And then they can go in and apply for more federal funding to plant new trees in areas. You can also use 3D Basemap for measurement. So anybody viewing this on a common browser can go in and measure how high a tree is or how high a signage is using that point cloud from the LiDAR. They can also go in and measure areas. So a roofer that's looking at contracting for a building can go in and see how much area that roof is. Or if there's been a tornado or a windstorm that comes through that rips up those buildings, you can measure that. Sea level rise and tsunamis and storm surges are important for a lot of cities. This one's actually in Grenada, which was in the plenary. I extracted all the buildings and a bunch of the other features for that, trees and other things that go into that. And this was the first actual country whole country that I was able to map in LiDAR. Admittedly, it's not that big of a country, but for me, it was the first country. And also in Grenada, we looked at the potential landslide areas. So they have a large issue there with it being a volcanic island, with the earth being, with all the water they get and storms, that landslides are a huge problem. So being able to take those landslide areas that they've identified and visualize them in 3D to see what they would affect, which buildings would they affect, what power lines would they affect, the roadways that they would affect. And be able to get that in context in 3D is a lot easier for people to see and understand because they can recognize features in there that they know. Below that is tree encroachment on power lines. So part of our new deep learning that you can get from ArcGIS Online, there is a module there that you can run with our deep learning tools where you can actually extract out power lines. So what you're seeing there is the LiDAR points in yellow that were identified as lines, and then the blue that was identified as the power poles themselves. And then you can take those and actually convert them to features using the 3D Basemap solution to where you get the catenary lines of the power lines going through there, angled down. And what I did was I did some further analysis where I converted those over to actual points, did some analysis with buffers around those lines, and then selected the LiDAR points that were in those buffers and converted them over to actual point features and symbolize them this way so that they can actually see where the trees are actually close to the power lines. So the green you see there is largely the trees from the LiDAR, and how it areas where it could possibly do vegetation encroachment where you may want to cut back the trees. In Kentucky, is helping them a while back with tourism issue. They had a state park, and we were able to take their fall colors and colorize the LiDAR point cloud to really give a neat effect their view of their state park. And below there, we're showing actually the terrain, and you can see all the trails in that terrain underneath the canopy there very well with their hillshade. And that hillshade was something they had statewide, but being able to take that hillshade and present it in a 3D environment like that with the elevation really allows it to pop out and be able to see the terrain better.
Hey, Arthur, we actually have a question that came in on your flood work, I think, in Granada. Do you know what format flood data can be brought in as, and can it be a time-aware raster?
A time-aware raster, I believe it can be, and you can put in a time-aware raster. I'd have to double check on that though. I know that I've brought in multiple polygons and then had them at different levels so that it shows the level of the rise of the flooding. In fact, years ago, I did that for St. Charles when we had a levee breach here in the city I live in. And I was able to show multiple amounts of how high the possible river or the flooding area could rise with the Mississippi where a levee breach was. And it turned out to be extremely accurate that way, and be able to see what buildings would be impacted by that flooding. But as far as a raster layer, you should be able to bring in that last raster layer. The whole point though is that you're going to be setting it to a certain height. So you would probably want to take that layer and do an offset for each of the different time periods based on the time, so it has an actual elevation it will go to. You may be able to just set it up as an elevation layer that will show how the water would rise. But I'd have to look a little bit further into that. I haven't done it with rasters before, just polygons.
Okay, cool.
So I did a quick search on Arizona and I actually found some examples. One was some buildings that were Phoenix 3D that was out there as sort of a base map. And all they did there was actually take the OSM buildings that were already published as a layer and then take those, add them to a scene and elevate them using the heights that were in them. It's not highly accurate, but it does give you a quick representation of an area. And it doesn't look all that bad, but a lot of those buildings are fairly flat compared to what they should be. I also found the University of Arizona in Tucson, and they actually had a base map that was very well developed where they have the floors in the buildings, they have the roofs, they've put a lot of work into that, and also the tree extraction and trying to get their trees right for the different symbology for the different types of trees that are in their campus. There's also a mobilized colorized point cloud from NC Tech that was out there of downtown Phoenix, where it's actually showing mobile LiDAR from the ground. And I thought that was really neat, where you can take that and actually bring it in with other data sets to show that. I'm going to stop my slideshow here and show you kind of this Phoenix scene, which I thought I took the buildings from the OpenStreetMap and then brought those in just so you can get an idea of how you can coordinate and bring these two different data sources in together. Of course, you'd want to probably get your buildings a little better, but this allows you to really get down into the street levels and see the LiDAR that's there from the ground. You can see the power lines, you can see the trucks actually, and the storefronts there. And this is mobile LiDAR where you're able to see the ground as well. Some things come in blue because it's actually getting the color from the sky instead of the color of the feature. But it does, and then you can actually take this and mix it with aerial LiDAR as well. And you can see some of the buildings in here and how they line up or don't line up with the 3D buildings from the OSM. It's actually not that bad in that particular place. And be able to move through a city and see things like this. And you can do, and as I said, you could do the same thing with colorized LiDAR from the air where it would cover the roof, and I'll show you that in a minute. So this is the data that was actually produced for the Tucson buildings, where one of our urban people took this as a demo for Tucson, where they took all the buildings and made them 3D with just basic heights. And you can zoom around here and see the buildings come up, and they're just extruded to the height of the building. It's what we call an LOD1, but it still has a neat view. And then we can go into the University of campus that I've shown you a picture of and see how you can see the buildings, and actually go down to a street level and see their really nice trees that they've been able to extract and how it conforms with the buildings that they did rather well. So what I'll be also showing you today is, and I think I'm just going to show you a demo first before we get back to the slides, just so you have some idea of what I'm talking about with that. When you start up if you just bring in your LiDAR as is and colorize it, it's going to look like this. And you can kind of see here where you have some floating buildings and it's colorized. There's a lot of holes in the buildings with the point density that's there. You can increase the point size of the points. But what I found over time is there's some tricks you can do to really fill that in with your colorized. So if you actually take your building footprint, or your LiDAR and classify it for buildings to where every point here that's part of a building will actually have a class code on it for building. And that's just a tool that you run, the classified building tool. Then what you can do is actually take that and extract it out and publish it as another layer and replicate it over and over again. And what that can give you is sides of buildings. So here, what I've done is done the sides of the buildings, just using the points that were classified as the rooftop. But it gives you a much better view. And then I symbolized them a little different, where I took one layer and made it really dark with the intensity. And how I set that up is I just have multiple layers here. It's all the same layer for the ones that are buildings, and just have it over and over again with negative offsets that you just set up in the symbology. So I just got in here and set to the source color, and then put the offset here. I usually keep it named the same so it's easy to keep track of, and just added this layer over and over again. Then the next step after that is to be able to add the trees in. So you can, since you have the buildings there, you can add the colorized trees that you have as well. So these are just point clouds here representing the trees. And then you can also go in and extract the buildings. You can use the LiDAR itself to go in and extract the buildings individually. And all it's doing is putting a bunch of attributes on it, like the building height, the roof form, the eave height if acceptable. So if we click on this building, it'll show us the eave height, the fact that it's a gable versus a flat roof. And then it's also got a base elevation and a roof direction. One thing that's not in the 3D Basemap solution I'm showing you is a tool that I'm trying to get in there right now, is actually gets the color of the roofs and from your imagery, and just applies a hex color that you then use to symbolize your roofs with the standard symbology in the 3D Basemap. So if we go from there, you can also extract out the trees themselves. Unfortunately, I had the wrong layer set up here. So these are the trees that were extracted out using the 3D Basemap solution. And you can actually turn on the LiDAR to see how they line up or do not line up with the LiDAR that's there. So this is using a solution. There's three different ways you can collect trees, actually 4. This is using the the trees from LiDAR Solution, and then there's also a very similar one in the 3D Basemaps called from surface elevation, from surface. And then the other way you can represent trees is just by having the trees actually with trunks. So if we turn on the trunks, you can see that there's actually trunks here. So what I've done is taken those same 3D trees that I had before, like this, that are more rounded, and just displayed them as trunks, tree trunks, and then using the actual point cloud itself to represent the tree, which better represents where the tree lies and how it is, and that just adds a little bit more realism to have the trunk come down from it. And it's pretty good for visualization. Admittedly, when you have a lot of trees, it does take a little bit of time to load up, but you can see it looks fairly good here and with the 3D buildings. You can also display your elevation, your LiDAR in different ways. So you can show it with a classification. So this is the classification of the LiDAR, but it's also modulated with the intensity of the LiDAR. And the intensity is where, when the LiDAR comes down and hits an object, how big of a return is reflected back to the sensor. And it looks like this with intensity, if you just show intensity itself, but we often use it to modulate so you can better see features with like the elevation. So this is showing elevation in different areas of the city. And then also you can have the buildings there as 3D features and then use the actual building roofs as well. So one of the more complex buildings here was this one. And on complex buildings, a lot of times you're going to have to manually actually divide them. So in this case, I actually took the LiDAR building that was automatically extracted. As you can see, the rough is, I cleaned this up a little and did a circle here. And then I split these features manually to be able to get those roofs in those areas. It's not going to do that automatically, break those all up. But a lot of times in other buildings, it will automatically break it up somewhat. And then you run it through the roof form tool that I'll talk about, where it will give it those different heights. So I'm going to go back now to the PowerPoints again. So I showed you this one. Oops. So here's some examples of some 3D Basemap Solution users. Sandag actually is the San Diego County regional group, and they actually can have San Diego County, and a lot of the municipal cities in their area involved in this. And they've actually done a 3D base map of their entire county, where they have every building represented, and then also the trees collected as well. The city of Las Vegas has it all in 3D as well. And I actually helped them with extracting the building footprints for a lot of that. Wolfsville does, Ryerson University does, GeoSim, City of Baywater. And then I was going to show you some of the ones I've worked on fairly recently, especially Connecticut Capital Region Council of Governments is about 1/5 of the state right now. And now they have 3D base maps for about 1/5 of their state. They already had the LiDAR published that way with as a base map layer, and they wanted more, so they ended up going in and taking their building footprints that they had and making those 3D for about 1/5 of the state. And they're going to be working on doing the rest of the state, so they have one cohesive statewide 3D building footprint for the entire state. And you can see there that it's actually broken up into the different levels with segmentation of the roofs. Aspen, Colorado recently called me. They were having some issues with trees and using that tool, and I was able to help them right away. But I also suggest that they colorize their roofs. So they used a tool I developed to add color to their roofs. And they use it for tourism and then also just for visualizing, see the ski slopes in their town, and also for inspections and be able to look at areas and understand in 3D what a new structure being built would look like, things like that. Chicago and Cook County. Cook County is currently building their 3D base map for their area. Chicago, we actually helped them build a 3D base map. And they had some really interesting LiDAR called Geiger LiDAR, which has a lot more points density than normal LiDAR. And we were able to build some really neat scenes using that 3D point cloud. State of Connecticut, state of Delaware, I've helped them both with being able to take the point clouds and use them to have their entire states as 3D with using the colorized LiDAR. That way, anything they need to measure or look at, in the state of Delaware, they're actually using it for tax ditch purposes, which is something that is specific to them. And then they also have a lot of trees that they're trying to look at to see how big of an actual canopy area there is, because it affects the largest the canopy, the more of a tree root system you have, the more of a buffer between pollutants coming from cropland to actual rivers that go into the bays there that they're trying to keep from polluting. So the more they can actually see how much biomass there is there that would absorb those pollutants before they would get to the water. So what data do you need to do this? Pretty much you just need LiDAR, points, lines, polygons. You can use an integrated mesh. Integrated meshes, I was going to say, excuse me, come from, if you have orientated imagery, which is imagery from multiple angles of your buildings from a plane, and sometimes you can get that from some of the data providers like Eagle View. You can actually take that orientated views, and then we have a software called Sure that you can build those meshes with from that imagery. Also, Eagle View now is working with a company called Skyline to take their orientated imagery and provide you meshes. It is an upcharge, of course, but if you have already Eagle View as your customer of Eagle View, you may want to think about doing that and looking at their pricing to see how expensive it would be to create a mesh from the imagery, the same imagery you already used, to be able to create a 3D mesh of your entire city, or just a specific area if you want to look at it. There's also a company called Nearmap, and they do large areas of the United States with meshes as well, and they're available for purchase for you to be able to use. But one of the easiest things getting back to that is with this 3D Basemap solution, just taking your LiDAR, colorizing it, classifying it some, and then publishing it will give you a pretty good view overall of your city in 3D. And the data is usually free because it comes from the USGS. So that's an easy way to do this, at least to get that first step to 3D. Then you can go, I would suggest going to the next step if you want to take your buildings and make them 3D and have them stand up and be able to do analysis. And you can actually link those to your features so that you have the 3D base map there where you can highlight buildings for one attribute or another that you have connected to it. Then you can also publish these online. It's pretty simple. You create some scene layer packages of your 3D features, and then you load them up online and they show up in your scene and be able to modify what you have. So all these, as I talked about earlier, these are the output layers. So 3D base map, I was talking about tasks. Tasks are basically instructions, and they're linked to the tool. So when you open up a task, it actually opens up the task on how to do what you need to do and has detailed instructions on how to do that. So you can see here, these are all the tasks that are involved with 3D base map, and they're broken down into different groups as far as what you want to do. So if you're just wanting to get your ground elevation and maybe a normalized different surface area or elevation of your area, you can just go in and use the extract elevation services, and then you can take that will create your DTM, DSM, and DSM. And then you can take that and publish your ground layer with the tool. Walk you through that to publish it and put it up on ArcGIS Online, so you have your very detailed LiDAR elevation as your base map that you would put your buildings and other features in your base map on. A lot of times it's about as good as what's normally in the elevation currently, but its resolution is probably going to be about 0.5 meters versus 3 meters. And that can make some difference, but not as much as you would think. You can also publish your buildings, so you can create your buildings. And one of the first things there is actually extracting building footprints. That is a whole process for taking your LiDAR, classifying it for the buildings, and then it creates rasters from that. And then you use it walks you through how to use a raster function to fill in the gaps between that raster output. And then it actually will take that raster output and take the buildings in and go through a very complex process that I helped develop, where it uses the regularized building footprint tool to give you those nice crisp corners and even round features, and to do things in buildings at odd angles even will come out fairly well as long that. You can get there's a lot more to that you could get into if you wanted to, but the basic tools were pretty good for getting you 3D buildings. In the one that I showed you in Creston, Iowa, all those buildings were created just using the extract building footprints to get the basic footprints. And then the next thing was to pre-process the building footprints, which is a step where you can go in and actually break them up by different levels of, break them up by different parcels or heights. And then you can create your buildings, which is where it actually goes and gives it the 3D attributes. And we also have a whole process for reviewing and modifying those 3D buildings, and then publishing them as well, and adding textures. There's a lot there. Publishing floors is another one where you take those 3D buildings and break them up into different floors if you want to do analysis on floors. A lot of that's good for seeing what the views would be from those floors, being able to understand the volume on each of those floors. Bridges it's kind of new. It's where it's just taking the points and it runs through a similar process to what I did for extracting building footprints, where it creates a surface and a feature. Then it actually uses procedural rules to create the bridge structure that goes around above it or below it. Publishing trees is where there's a lot of different options I was telling you about. The three that are listed there, the first one is to classify trees and LiDAR using deep learning. And it says optional there for a reason. Classifying trees using deep learning on, say, a laptop can take a long time. We're talking like, for a city the size of Richmond, maybe 6, 7, 8 days of processing on a laptop just to classify the trees. But you don't have to do it that way. You can also use the extract tree points using surface analysis, where you're down to a few hours to process an entire city. There's also tree points using cluster analysis, which is another process. We kind of give you these different processes of what you want to do. If you have a small park, try the deep learning. And just limit it to that area. But if you're wanting to do a large city or a state, you definitely want to use something like the surface analysis tools and maybe set them up in a batch process where they run over large areas. I did do the entire country of Grenada by doing it in batch, where I set up a model around this tool to where it would do it in smaller segments as it went across the country. I do the same thing with large counties. Doing that sort of thing with a batch, I can actually run in and do a batch of an entire city or a county and 4 or 5 million trees over a weekend easily. And then it has for publishing the trees, and then power lines, publishing on the ground. And we're going to get a little bit more into all these. So I probably should have said a little too much there. So Creating a 3D base map, I talked about the elevation just now. The colorizing LiDAR is pretty simple. They're standard 3D analysis tools. You just go in and create a LAS data set, use this colorized LAS tool that's off to the right. You can set it up for red, blue, and green, but you can also add infrared as well as a color on there. And it just takes it and colorizes all the LiDAR and puts it into a new folder and a new LAS data set. And then to get it online, it's as simple as taking that LAS data set that's colorized, putting it into a scene, and then into Arc Pro in a 3D viewer, and then taking that and creating a 3D base, creating a scene layer package out of it, which is create scene layer package, point cloud scene layer package, and then taking that and publishing it, adding it online to your ArcGIS Online account, and it will automatically load it up and create a 3D view of it that you'll be able to see. And really, this is pretty affordable. It's basically about 1.2 credits per the month for each gigabyte. So you're looking at about 12 cents per month for each gigabyte. The entire state of Connecticut, once it was colorized, was only $840 a year to have this way, freely accessible to all of your users, and be able to bring into ArcGIS Pro and do analysis with. And when you think about, oftentimes for a state, LiDAR can cost tens of millions of dollars. It's a pretty low cost to have it available to everybody this way, have it colorized, and be able to be used. Some of the other 3D base map layers are when you take those and create your buildings from them. So your input there is going to be either building footprints that you generate through your LiDAR for extracting the building footprints, which I have below in the scene down here where it's where I've extracted the buildings. These are the ones for Crestwood that I was talking about, which were automatically extracted from the LiDAR. Or you take LOD2 buildings. And one of the first steps we try to do is break it up into different roof forms here using segmentation tools. So you classify your LiDAR for buildings, you generate your footprints, it automatically will take those and regularize those building footprints. And then we try to segment building footprints, which is a tool that's in there, which will take the DSM and actually break it up into the different areas here that you can see. And then after that, what it is it's running through the next step, which would be the roof form, to add the attribution segments such as the base elevation, the building height, eave height, the maximum height, or the roof form and direction. And that's all generated with procedural rules, and you get out these 3D buildings that match up pretty closely to the LiDAR, not perfectly, but pretty closely. And that's all under this published buildings that we were looking at before. And roof segmentation, I'll just talk about this a little bit more. One of the inputs you can have in this is actually parcel data. So I didn't use the parcel data on this, but you can see how the parcel data would have further broken up these buildings into different groups versus the manual and automatic segmentation that I did. And what I'll often do is bring it up with a hill shade of the colorized hill shade of the actual NDSM or DSM, and be able to view it this way, so that it's very easy to see when you zoom in where the different roof forms are and how to break them up either manually or if it's done it automatically correctly with the tools. But it's something you should check before you actually publish. It's not always perfect in the way it does it automatically. 3D base map layers. Once again, near and dear to my heart are trees. Originally, I came up with this idea for doing the trees, and since then, they've now had where you use a deep learning to classify your trees, but you can also go in and just take the general tools and run those for this tree point using surface analysis, which is what I'd recommend trying first on your area. And that's where you saw the trees that were from the local from Creston, Iowa, that I showed, where they were in that view. And one other thing that they didn't mention really in the 3D Basemap solution, but I've done, is actually gone in and used leaf off imagery and done an NDVI, a normalized difference vegetation index, which is the raster function you can apply to it. It uses the red and the infrared bands to where you can take that and add another layer and then use extract values to extract those raster values to those points. And you can actually use that to help to determine whether it's a coniferous or deciduous tree, or basically a pine tree versus like a maple. That will help you better break it out. And I have done some tests with trying to break them out even more species with some luck, but that gets pretty complex. But if you want to try the deep learning, this is a great opportunity also to try deep learning for the first time and using the artificial intelligence tools that we've developed. Bridges, as I was saying, basically they're a lot like the buildings, except you're just getting a flat bridge or a curved bridge, and then you're using the procedural rules to build up the architecture that goes above it. Another thing you can do is, I've done on some of my scenes, is actually gone in and just looked at third-party vendors. A lot of times you can import those from like SketchUp or other places, and then find a bridge that's similar or the exact bridge, and then usually you have to adjust it or resize it slightly so it matches your LiDAR, and you can get a very nice bridge that represents the bridge that you have without putting a lot of work into it. One of the things that's fairly new, that the first time I got to work with was on Grenada earlier this year, was where we were actually going in and using artificial deep learning to determine the points, like I was talking about, where these points are actually the points from the LiDAR that were represented as lines. And then these are actually the power poles here that were picked up and automatically classified as power poles. And then we can turn those into features and have those represented, like you see here, where we have the catenary lines and where the transmission poles are and the telephone poles coming in here. But it actually is a fairly intensive process, just like the trees is with deep learning. I would suggest you try to find a way to limit it to certain areas of the LiDAR. If you try to run it on a whole island or a whole country or a whole county even, it will take a long time to run. I suggest trying it with smaller areas, slowly breaking up. And if you have any features that show where those lines are, you can actually buffer those and use those to select the points using extract LAS to extract those out to a new feature class, a new LAS data set, and use that LAS data set to be able to pull in and bring into your analysis for the AI, and thus you limit how many points you're looking at and are able to greatly reduce the amount of time, often by 100 times less processing that you'll have to do on your computer. Underground pipes, I think I talked about that a little bit. It's just, again, bringing in the pipes and the 3D views. The 3D pipelines, being able to represent those in 3D underneath what's the existing city, so you can see how they connect to the buildings, how they interact with each other. I know here in St. Louis, they're using this to MSD, Metropolitan Sewer Department, is actually using this along with a lot of other ancillary data they have, like where the old tram line rails are, because they have to cut through those tram line rails to be able to often install pipes and be able to know where they are in relation to the pipes or the electrical systems or all the others. And St. Louis is actually going through an initiative where they're trying to get all the companies that work underground to work together and plan out where they're going to work at different times to upgrade both their sewer systems, their telecommunications, their power lines that are under there, and even their steam pipes that often heat large parts of the city. But this is a tool that can help with that. Floors is pretty simple. It's just taking that multi-patch 3D building and breaking it up into multiple levels for different floors. And it just gives you the floor plates and the volumes. One thing that's nice about this is then if you have actually floor plans, you can bring those in and you can make those 3D, and you can actually go inside the building and do some maneuvering inside the buildings that I've seen. And that gets more into the indoor solution that we have. I wanted to explain real quick about some of the different levels. So we've seen both an LOD1, which is just a simple extrusion. We've seen the LOD2, which is what the 3D Basemap solution will give you, where it gives you the heights of the buildings, and we'll break it up into different floor area, different height areas. You also have LOD3, which a lot of times, sometimes you can purchase, and they're usually fairly expensive compared to doing it yourself with an LOD2 with the Basemap solution, but you can get better looking results where it goes in and they've actually extracted all those features, and you get a little bit crisper lines, you get more exact details on it. And the last one is the 3OD, LOD3, where level of detail 3, where it's textured, where they've actually applied textures from imagery onto that. And the one that's not here is, of course, is the meshes, which is where that's all photogrammetrically derived. But we are working on ways to be able to take those photogrammetric derived meshes and break them out into individual buildings that will then be able to tie to attributes, so you can do more of analysis with them. But that'll be coming in the future. Yes.
Two things. One, you got about 7 minutes left. And then, not to jump you back, but there was a question about the underground utility extraction. Will invert heights work for that, or is something else needed?
Invert heights, you mean the height below ground is what you need for that. And then also the size of the pipe, which is usually collected, and usually the start and end height, so that you can get the slope of where the drainage line actually lies and goes. So you'll need the start height or below ground and the end height below ground for the pipes. Does that answer your question?
I think so. It came in from one of our viewers. So if there's more, I'm sure she'll put it in the chat. So I think so.
And I'll give you my email at the end. Let me go through this quick. So this is just talking about how we actually extract the buildings out. It just talks about the roof planes and how it gets the planes from the LiDAR, from the DSM that's built from the LiDAR. And then it drives attributes to give you the ridge height, the eave height, the ridge direction, and the roof form, which can be gable, hip, or flat. There are other roof forms available, and some of those are other ones. And you might have seen the slide in Chris's presentation, or Mark's presentation, where it goes in and it's using a tree. This is how the basic tree tool works for the surface. And also there's a previous tool called Trees from LiDAR that uses NAPE and that process. It gets you slightly better results that you can download from ArcGIS Online. And it's actually using the hydrology tools. I'm looking at redoing it with the hydrology raster functions, but it will work similar. Basically just gets the height of the trees. It grabs everything over a certain height and converts it to a digital surface model. And then it inverts that surface model and uses the flow direction tools and the hydrology to find out where your sinks are going to be. And then it uses the flow accumulation, which is how much flow flows into every pixel and how many pixels flow into that pixel, to take those sinks and give them the amount of pixels that flow into it, which then we can derive the crown diameter of the tree from, and that's applied to it. We also get the slope, the NDVI, the crown diameter. With the trees from LiDAR, we don't get the NDVI with the surface one that's included in the 3D Basemap. And then remove trees that are too close to buildings. With the trees from LiDAR, you actually retain all the points. You can change the selection on it. The other one with the 3D Basemaps, they tried to make it a little bit more simple and easier for users to use, so you don't have to do that. I'm going to skip through this, but if you're interested, take a quick screenshot, because this is how to do contours with contour functions, and it just explains that. It was for the demo I did yesterday. And then spot elevations, this is a raster function chain, which is very similar to what I used with Mark for his forest to get the tree heights, but in this case I was mapping mountain heights and hills, and it's something that's adaptable where you can then get the spot heights for high points, or you can invert it and use it for low points to get parts that are low as well for spot elevations if you're doing cartographic mapping. And of course, hillshades you can do with a function as well. This is something they asked for. One final thing is I work for the Community Maps team, and I don't know how many of you are contributors to Community Maps, but if you are, that is great. If you're not, think about it. It's a way of getting your data into our Basemaps, and we also have a way to provide feedback if you see something wrong with our Basemaps. And we also have this new edit features, which is actually a web browser where you can add features for special items like campuses or parks that you want to add into it. And I was just going to see if anybody has any questions now. Anybody else have any questions they want to bring up?
Let's see if anybody writes one into the question forum.
I forgot to do my final slide. I'm sorry.
While we wait for questions, I'm always just reminded of how little I need to do more with my LiDAR data. Like, I need to be doing more.
Well, lately I've been working on vector tile hillshades of the entire world. So there's things I would like to do as well. This sort of thing keeps me from some of the monotonous work that I do, which we all have to do at different times. This is my email. If you have any questions on any of this presentation, or you want to see a slide, or you want to have, if you want, somebody yesterday asked for the tool to give the color to the roofs of the 3D buildings, and I was able to provide that to them, and it just goes into your imagery and grabs a height, or it grabs the RGB values, converts it over to hex, and applies it as an attribute to the buildings that then you can symbolize as your roof color. You can also use it to get a bunch of random colors from what I use as houses for sales in an area, and just throw that as an image into Pro and draw some polygons over the colors I want, and then run the tool, and it'll give me a set of random colors to apply to the sides of buildings. If you want to do that as well, there's a city interested in doing that. But there's a whole host of things, or if you have questions about trees from LiDAR tool or some of the other tools in the 3D Basemap, email me. If I don't know the answer, I can usually get the answer for you.
Great, cool. I think that takes us right to the end of our time. There's no questions coming in. So Arthur, once again, thank you so much for coming and speaking. This was absolutely amazing. As I said, it leaves me thinking, wow, I just need to do more with my LiDAR data. So, and if the folks out there are interested, please always feel free to come to our LiDAR work group for AGIC. Arthur has presented there a couple of times as well. So, and it's where we talk about a lot of this stuff. So cool. Mariah, was there anything else?
And as a reminder to everybody who joined the session, Arthur's presentation, the video recording and his slides will be available on this page within a couple hours or later this afternoon. And if you could be so kind and take the survey that's on the right-hand side of your screen, I would greatly appreciate any feedback that you have. We take it into account, as always, for any further conferences. So again, yes, thank you, Arthur, for coming here today with us and sharing your knowledge, and thank you for everybody to attend. Yeah, hope you guys have been enjoying the conference, and Arthur, hopefully we can see you in person maybe next year at the conference.
That would be great. All right, thank you.
Thank you, everybody.